this. Then I'll make a current I to flow. Let L be the B be the unit per width and L be the length. The separation between them, let it be. So I want the self-inductance of this given structure. So these are the plates. This is a plate 1. I'll give a condition L very much greater than B. This is very much greater than it. So there's a plate 1. There's a lower plate 2. So it's a one turn. It's a one turn. Okay, these are the connecting wire. Find the self-inductance of the system. How to find out this one? So what is the only basic formula? What we have is like, you have to take help of the basic formula. What is the basic formula? What it says is like, self-inductance we define as flux linking per unit current. Flux linking the system per unit current flowing in the system. The ratio of that is what self-inductance. So we'll try to find out the flux produced by that. Okay, here I suggest you go for AB. Already we have symbols. We'll take some other symbols. Let me choose. This is P1, P2, P3, P4. This is P5, P6 not visible, P7, P8. So then what you see is like stand here. Then you can see like this a current carrying sheets. The upper plate is a one current carrying sheet. The lower plate is another current carrying sheet. So this will become P3, P4. This will become P1, P2. Here you can see current is entering into it. And here you can see that current is coming out. So what is the lambda will define? Current per unit width, I by B, the lambda. We'll define here lambda. Go for Ampere's circuit law. The field produced by 3-4 here will be in this direction. And here it will be in this direction. The field produced by P1, P2. And look at this field. So it will get nullified external to the plates. Only in between plates, the field is confined here. The resultant field will get added up. Okay, what about what is our question? We have to calculate the self-inductance of the system. And we know that this is field produced by P1, P2. Simple. Okay, let me use like P3, P4. So you have to just get only the flux in all these problems. So field produced by P1, P2 is equal to P3, P4. And it is equal to how much? Mu naught lambda by 2. From where this particular formula came? Ampere circuit law. I need not to show this again and again. By this time, you should understand the field produced by a current carrying sheet is given by mu naught lambda by 2. What is lambda? Current per unit width it is. So whatever the net field inside between the plates, point P, I'll write it. The net field at point P is given by P34 plus B P1 P2. Can we calculate the flux? How to calculate flux? Flux linking the gap between the plates. So we'll write it here. Gap between the plates. How much it should be equal to? It should be equal to BP. What shall I write? Area A into L. Don't write this area. Your B bar will be in this direction. So no, sir, not understanding. Not understanding. Okay, come for this. You should have a patience to draw as many as diagrams so that things will get clarity. Here, the B bar will be in this direction. I will write here. Now, what is this? Net field BP. At least looking at this diagram, can you say anything about the area of this gap? Here, this face, the B bar will be into the plane. So flux is what? BP into this area. This is AL, no? Okay, what is value of BP? It's equal to mu naught lambda L. What is further? Lambda is I by B. Now, how you define self-inductance? Flux linking to the unit current. Mu naught ALB. So this is the self-inductance of this structure. The first one we are doing. In some applications, so only one turn. Are you seeing that only one turn? Now you may get some doubt, sir. Plate, how come this one turn? I think if you stand here, what do you see? Like you see only one turn here, no? What is the self-inductance of this structure given by this particular formula? We'll do one thing, self-inductance of ring will calculate. Okay, so please note it down. These are very popular. I'm telling this one, in especially advanced, no, they didn't go for a very high level. Small ideas is what they're trying to bring in the exam. We know self-inductance, we know mutual inductance, but the small ideas of this kind, definitely little bit you have to put effort here, because we know basic definition. What is the basic definition says? Flux linking the coil to the current in the coil is self-inductance. Getting that calculation of flux is what biggest headache. And now self-inductance of ring will calculate self-inductance of a ring.